Welcome back for 5.2, direct variation. One of the things that I'm excited about for at least direct variation is that we worked pretty well with it last year, and so I'm confident that we'll be able to, at least on a basic level, have it right off the bat. So your essential question for the day: how do you identify a direct variation relationship? So I would like you to make a direct variation relationship with your arms. Do you remember? So your right arm should be going up, your left going down, and what does it go through? Yes, it goes through 0, 0. So let's look. So you're making your notes, got it all set up. This is awesome. All right. Would you write down direct variation? And then let's see what we should write down for a definition. It's a relationship that can be presented by the equation y equals kx. This is going to be super duper hugely important. We worked a bit with this last year, but we're going to really go in depth this year, and hopefully that will go well. So y equals kx, that is our most important thing that we're going to look at all day. All right? So k is the constant of variation. So this is really super important. Right here, that's your rate of change, but it's also your constant of variation. So k for constant, because in German, constant starts with k or something. I don't know, I'm just making that up. All right, next slide. Here we go. So which is the equation that would show a direct variation? Yes, that would be this one right here. So does this represent direct variation? If so, find the constant of variation. Well, right now this does not look like this bad boy up here. So we've got to do a little bit of tweaking to make that happen. So let's see. I'm going to rewrite it. So 4x plus 5y equals 0. I will tell you right now, because of this 0, yes it is. So now, because of this 0, it is going to be, and I'll show you why in a moment. What we've got to do, we've got to get so that the y is over here by itself and the x is over here. Well, looking right now, how is this 4x put onto there? It's added, and it's added because there's an invisible plus right here, not because of this one. So I'm going to subtract the 4x from both sides. All right. If that's the case, I'm going to move this down. If that's the case, what do we have there? Well, this cancels out, so I drop down my 5y equals negative 4x plus 0. Do I even need to write that 0 there? I don't, so I'm not going to next time. And then my ultimate goal is to get this y by itself. So how do I undo 5 times y? You've got it. You divide by 5. So I get y equals negative 4/5 x. Now you might say to yourself, all right, but that's negative. Yeah, great question. I guess I haven't thought that it would be negative, yet at the same time, does it fit this? Yes. So it's directly varying even if it's going down. All right, so this next one, 3y plus 4x equals 8. Is this one going to be direct variation? And I'm going to tell you right now the answer is no, and it's the 8's fault. When I look up at here, it's always y equals kx, and there's no plus something on the end. There cannot be a plus something there. So if I solved this one, I'd get 3y equals negative 4x plus 8. So this right here is what messes it all up. It's the 8's fault. If it had been 0 right here, would have been okay. So now, can we figure out if it is direct variation? Hopefully. And now we go to the next thing. Suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y? All right, the first thing I'm going to do is that I'm going to write down y equals kx. All right, and That's great. My ultimate goal is that I figure out what k is. Okay, that's my ultimate goal. Right now, I don't know it. All I know is that y is 35 and x is 5. So what should I do? Well, second thing you can do, plug in your given x and y. So my y is 35. So I've got 35 equals k times 5. If that's the case, can you quickly see that 7 equals k? Excellent. So if 7 equals k, then, oh gosh, hold on. If 7 equals k, that's great. So this is super helpful for me. But am I done? No, because look at this little arrow over here. Isn't this cool? Make sure you don't stop at k equals 7, because my ultimate goal was to find this equation. So 3, now you rewrite with k. So y equals something, x, we found that k was 7, so my equation is y equals 7x. So you start with your y equals kx, you write it down, you plug in what you know, y was 35, x was 5, and you figure out what k is, and then you rewrite it. Now it says, what is the value of y when x equals 9? Well, don't let that make you nervous. You've got y equals 7 times, in this case, 9. So when x is 9, y equals 63. All right, we're going to stop for a second. I'm going to have you try a couple of those on your own, but it's going to look strangely like a word problem. Space exploration. Weight on Mars, y, varies directly with the weight on Earth, x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So the weight on Mars was 50 pounds. The weight on Earth was 130 pounds. What is the equation that relates the weight in pounds on Earth, x, and the weight on Mars, y? Okay, so the first thing, you can push pause if you want to do it by yourself. Otherwise, you can just watch with me. So y equals kx. That's my first thing. Now I'm going to take and I'm going to sub these in. So y, it says y is Mars. So Mars was 50 equals kx. And x was Earth. Earth is 130. So therefore, to find k, I divide by 130. I divide by 130. Look at that, 0, 0. So I'm going to divide both by 10s when I simplify. So k equals 5/13. What is an equation that relates? So now I'm going to take this. I'm not done. I found k. Awesome. Great. But my ultimate goal was to get an equation. So I'm going to have y equals, fill this back in, 5/13 x. Woofda. There is my equation. So what is the graph of the equation in part A? Well, they counted by 10s this way and by 25s this way. Is that okay? Yeah, it is. So 0, 0, and this was 50, and, oh gosh. Oh, wait! I don't know, hold on. All right, I had to stop and gather my thoughts for a second there, because I was like, hey, wait a second, how in the world did they get this graph out of that? 50, 20, how did that work? Well, watch this. Yes, 5/13 is our slope. And generally, I'm going to leave my slope as a fraction because it's just easier to work like that than my rise over run. I can just rise 5, run 13. But in this case, because we're in a real world problem, what I want you to do, I want you to take this and I want you to do y equals something x. I want you to quick grab your calculator and figure out what that is as a decimal and round to the nearest hundredth, and then come back to me. All right, when I did that, I got 0.38461538. Is that what you got? Yeah, so I'm just going to round that to 0.38. All right, if that's the case, I could quick make a chart, because when you're not sure how to graph, you can always just make a chart. Now, if I put 0 in, because it's direct variation, I know it goes through 0, 0. Then I'm going to try 50, and I'm going to plug 50 in there, and I would like you to do the same. 50 times 0.38, I'm going to get 19. Ooh, that kind of turns out nice. Now, if that's the case, would you expect that this, I'm guessing 100, is going to be about 38? It should double, but let's, oh yeah, because 0.38 times 100 is 38. And then I could do 150, and so that's what they did. Do you see, let's see, I bet it'll go up by 19 again. 150 times 0.38. Yeah, so I end up at 57. So that's how they graphed. So you can go through once you've done this, and you can just make a nice little graph of it. So that's good for now. We're going to stop, and we'll come back to class, and we'll do a little bit more tomorrow. See you then.